Hi Trigoners, these are Note 6.3 Part 1. Go ahead and pause the video and read your 4 objectives for this lesson. Okay, welcome back. So we're going to continue talking about rotational angles and reference angles. So this time we're going to be given the rotational angle and radius, and we are not going to use a calculator. We're going to use special triangles to sketch a graph of the angle theta in standard position, find and label the reference angle, find the coordinates of the terminal point, and find the sine of theta, the cosine of theta, and the tangent of theta. So let's go ahead and start with that first problem. So if I have a 60-degree angle, I start at the positive x-axis, I'm in standard position, and notice that my terminal side is in quadrant 1. So an angle on standard position and that has a terminal side in quadrant 1, notice this reference angle is 60 degrees because we're always going to consider the terminal side with the x-axis. So now we know that opposite the 60 is the x root 3. Side opposite the 30-degree angle is x, and the side opposite the 90-degree angle is 2x, and we know that the radius is 10. So the 2x side is 10. So we know that the x is 5, and the x root 3 is 5 root 3. So the last thing we need to do is find the sine of theta, the cosine of theta, and the tangent of theta, and we're using the reference angle. So go ahead and pause the video and find the sine, the cosine, and the tangent. We're using SOHCAHTOA. We have the sine is opposite over hypotenuse, the cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. So the terminal point would be, I would need to find the x and the y. So I went right 5 and up 5 root 3. So that is my x and y coordinate. Go ahead and pause the video and try part 2. So for part 2, we had an angle at 150 degrees in standard position. Our reference angle was 30. So we know that opposite the 30 is x, opposite 60 is x root 3, and opposite 90 is 2x. So if they told us the radius is 4, we can find the side opposite the 30 and the side opposite the 60-degree angle. So we know that the terminal point is negative, because we went left, we're in quadrant 2, negative 2 root 3, comma 2. Terminal point in quadrant 1 had positive x and positive y. Our terminal point in quadrant 2 has a negative x and a positive y. Notice for sine of theta, cosine theta, and tangent theta, we did opposite over hypotenuse for sine of theta and had 1/2. Cosine of theta was adjacent over hypotenuse, and tangent of theta was opposite over adjacent. So let's go ahead and try number 3 together. 225 degrees. The terminal side of that rotational angle is in quadrant 3. 225 minus 180 is 45 degrees. The reference angle is 45 degrees. Pause the video and find the missing sides of the triangle. It might have been a little bit trickier because we were given the radius was 1, and that is the side corresponding to the x root 2, so it's opposite the right angle. So we know that the x root 2 is equal to 1, so x is 1 over root 2. If you rationalize, that's root 2 over 2. So we know that the x and the y coordinates, the sides opposite the 45 degrees, those are root 2 over 2. So our terminal point, we would go left root 2 over 2 to get to this location. That's our x, and our y is negative root 2 over 2. So that is our terminal point. So lastly, we need to find the cosine of that angle, which is adjacent over hypotenuse. The sine of that reference angle, which is opposite over hypotenuse. And the tangent, this is interesting that the tangent is opposite over adjacent. Well, that is 1 because root 2 over 2, negative root 2 over 2 divided by negative root 2 over 2 is 1. So go ahead and pause the video and try number 4. We have a rotational angle of 330 degrees, which gives us a reference angle of 30 because 360 minus 330 is 30 degrees. But notice that if the radius is 2x, is 2, that's the 2x side, x is 1. Notice that we have a negative 1 because you are going down in the y direction. So we have a negative 1 and a root 3. So our terminal point went right root 3 and down negative 1. Now if we want to find the sine of theta, that is opposite over hypotenuse, which is a negative 1/2. The cosine is adjacent over hypotenuse, which is root 3 over 2. And the tangent of theta, which is opposite over adjacent, which is negative 1 divided by root 3. So if you use a calculator, go ahead and grab your calculator right now, and if you try sine of 30 degrees, make sure you're in degree mode, and sine of 330 degrees, see what happens. Go ahead and pause the video and give it a try. Are you surprised that the sine of 30 degrees is 1/2 and the sine of 330 is negative 1/2? Doesn't that actually make sense? Because 30 degrees would be a quadrant 1 angle. Notice the terminal side is in quadrant 1, and the sine is, notice it's positive, because the sine would be opposite divided by hypotenuse. So actually the sine would be, and again, I guess you could fill in the root 3 over 2. So if you're looking at the terminal point, do you see how the sine would be positive because the y-coordinate is positive? Interesting. Okay, so in 330, notice the y-coordinate was negative. Very interesting. Okay, so we're going to talk about positive and negative trig ratios now. So we want to know where the sine is positive. So let's think about this. So first of all, when we're thinking about that radius, the radius, that is a distance from the origin. So it's a distance, so we're always going to consider that as positive. But for example, think about a terminal point in quadrant 1. We went right and up, so that's positive for your x and positive for your y. In quadrant 2, you went left and up, so your x is negative, your y is positive. In quadrant 3, you went left and down, so your x is negative and your y is negative. And in quadrant 4, you went right and down, so that's positive and negative. So for example, if we were in quadrant 1, the sine was opposite over hypotenuse. So positive over positive would be positive. The sine in quadrant 2 would be opposite over hypotenuse. Positive over positive is positive. So the sine is positive in quadrants 1 and quadrants 2. But if you take a look at quadrants 3 and 4, if I wanted the sine of that angle, that reference angle in quadrant 3, for example, would be opposite over hypotenuse. So negative over positive is negative. And in quadrant 4, the sine would be opposite over hypotenuse. So again, negative over positive is negative. So the sine is negative, the sine of theta is negative in quadrants 3 and 4. Let's think about the cosine. So the cosine, if we look at quadrant 1, here's right here in quadrant 1, notice the cosine is adjacent. The adjacent would be positive, and positive over hypotenuse, which the radius is always 1, so positive, excuse me. So positive over positive is positive. So in quadrant 1, notice the cosine is positive. In quadrant 4, notice if you have quadrant 4, the cosine is adjacent over hypotenuse. In quadrant 4, you will have a positive cosine value. But if you're looking at quadrant 2, adjacent is negative. And in quadrant 3, adjacent is negative. So for the cosine of theta will be negative in quadrants 2 and 3. Go ahead and pause the video and try and see if you can figure out where the tangent of theta will be positive and where the tangent of theta will be negative. Okay, so in first quadrant, notice that the tangent of theta would be opposite over adjacent. So that would be positive. And in the fourth quadrant, the tangent is opposite over adjacent. Negative divided by negative is positive. So the tangent of theta is positive in quadrants 1 and 3. In quadrants 2 and 4, notice that if you have theta, tangent is opposite over adjacent. That's positive over negative. And in quadrant 4, opposite over adjacent, negative over positive. So quadrants 2 and 4 would have tangent of theta would be negative. Okay, so now we know where everything is positive and negative. Let's see, let's go ahead and start talking about some problems. So for example, if I say that the sine of theta is 0.73 and the cosine of theta is less than 0, it's negative. The first thing I want you to do is pause the video and see if you could figure out which quadrant this angle lies in. Where is the terminal side of this angle? Okay, so hopefully you figured out that the sine is positive and the cosine is negative in quadrant 2. So the sine of our angle is, you could say 0.73 over 1 if you want. So notice, now I'm asking you, what about the sine of theta? So again, we were thinking of, you could think of theta reference, you could think of, but I'm talking about the theta, the rotational angle, here it is. So if I added 180, notice that is over here. So what I want you to do is see if you could figure out what would the sine of that particular angle be. Give it a try. Pause the video. Okay, so did you realize that you'd have to have the same reference angle, right? Because you're adding 180. So notice if I add 180, that I have theta plus 180, and There you go. So I need to know what the sign opposite over adjacent would be. And notice it would have to be negative 0.73 because, again, now you're in quadrant 4. And that y-coordinate is, the y-coordinate is negative, and we went down. 0.73. So go ahead and pause the video and see if you can go ahead and draw a picture for number 9. Hopefully we're able to figure out that our theta would have to be in quadrant 3. The terminal side's in quadrant 3 because that is the only quadrant that has a positive tangent and a negative cosine. So now I want to know if you add 180, so that would be all the way over here. Add 180 to theta. So now we are in quadrant 1. So go ahead and pause the video and see if you could figure out what would the cosine of theta plus 180 be. We'd have the same reference angle. Okay, so do you see how the cosine of theta plus 180, or the cosine, is positive in quadrant 1? So your answer would be 0.23. Let's try and draw a picture for number 10. Number 10, I told you that you had a 112-degree angle. So if you wanted to, you could find the reference angle. 180 minus 112 is 68. Reference angles are always with the terminal side of the rotational angle and the x-axis. So now I'm going to ask you some questions. Okay, so the tangent is negative 2.48. So let's say now I wanted the tangent of a 68-degree angle. Notice same reference angle. So if the tangent of 112 degrees is negative 2.48, what would the tangent of the 68-degree angle be? Go ahead and pause the video and think about that. So we knew that in quadrant 2, we did the tangent of 112 was opposite over adjacent. We got negative 2.48. Notice the tangent would have to be positive in quadrant 1. So you would say positive 2.48. Go ahead and pause the video and try B and C. All right, so for part B, 248 degrees in quadrant 3, the tangent is positive. And in quadrant 4, for part C, the tangent is negative, so negative 2.48. Now for go ahead and try cotangent of 292. So looking at the same picture now, could you find the cotangent? Go ahead and pause the video and give it a try. All right, so looking at this angle, get my highlighter, looking at this angle for 292 degrees, notice the cotangent is 1 over tangent. So you would have to go ahead and do 1 divided by negative 2.48. All right, so for number 11, you are given a terminal point, and you need to find the reference angle, the radius, and the rotation angle. So let's do part A together. Negative 4, negative 5. If that is my terminal point, I'm in quadrant 3. I could go ahead and do the Pythagorean theorem to find r, the radius. Go ahead and pause the video and solve for r. Okay, hopefully you got r equals 6.40. So I found the radius. I would like to find this angle. You could use tangent. The tangent of theta is opposite over adjacent. Now go ahead and type this into your calculator and see what happens. And this is where it helps to understand reference angles. Notice that when I used my calculator gave me an angle for a reference angle of 51.34. And again, my calculator, that's giving me the reference angle. My calculator is thinking that I'm in quadrant 1. So if my reference angle is 51.34 degrees, I could find the rotation angle, and I'm in quadrant 3, so I would have to add 180. My rotation angle is 180 plus the reference angle of 51.34, so 231.34 degrees. So why don't you pause the video and find the radius and the rotation angle for part B. Go ahead and pause the video now. So this is kind of interesting. I found r. I went ahead and used the Pythagorean theorem, but when I used my calculator to find the angle theta, Inverse tangent of negative 2/5 was negative 21.80. So my calculator doesn't understand that reference angles are positive. My calculator actually returned an angle, since this was negative. It returned an angle in the fourth quadrant. But if we understand that that's a reference angle, I could find my rotational angle by doing 180 minus the reference angle. So the reference angles are positive, is 21.80 degrees. So if I do 180 minus the reference angle, so let's do 180, it's negative, you end up with 158.20. So I found from a terminal point, I was able to find the reference angle, or sorry, the rotational angle and the radius. Okay, so our last problem, we are going to try and draw a right triangle, but you have to figure out which quadrant would have a negative cosine and a negative sine. Pause the video and think about which quadrant would have which quadrant would have that angle theta. So the cosine is negative and the sine is negative in quadrant 3. So I know this is a 7, 24, 25 triangle. So now I need to find all the other 5 remaining trig ratios. If the cosine is theta is negative 7 over 25, the secant is the reciprocal. Looking at my drawing, my sketch, my sine of theta is opposite over hypotenuse, so that would be negative 24 divided by 25. So the cosecant would be the reciprocal. And my tangent of theta is opposite over adjacent. So the tangent of theta is positive in quadrant 3, 24 over 7. So the cotangent of theta is the reciprocal. So nice job, everyone. Those are notes for part 1 of section 6.3.